I mean, I have the presentation. I guess.
Ah, no, there he is. We're safe. I'm safe.
Okay. At least he's trying to connect.
Yes. Yeah, no.
Good morning, Chidi. Do you hear us?
No.
Oh, yes, I can hear you.
Excellent. You sent the presentation. Do you want to give it?
Yes, please do so.
So do you want me to share, or do you share your screen yourself?
Okay, so it does better is as identical same, I think. Let me open it.
So I didn't get it, the last part of what you said. Could you repeat? Actually, could you repeat what you previously said? Okay.
Yes, I think I can share my screen also.
Okay,
well,
yeah, excellent. Yeah, we see.
Okay, so I'll do ITR part, and I think Alex can will do the ITT part.
Yes, yeah. Hi, guys. I think I'm stopping my video because I'm not speaking, right? You have seen me. Hello. I turn it on again when I speak. Yeah.
Okay, so welcome to the quality-related IT activities. Usually we have IRG-ABQA meeting during the BCAN meetings, but since the last ITU meetings, ITUR and ITUTs, ITUT side didn't have any meetings. So next ITUT study group 12 meeting in June, and ITUR in fact met in March, but because it was online, we have some limited activities. So there are some issues related to qualities, but not much. So this time we decided to have just informal sessions to present IT activities to weaker communities. So I believe that some activities, ongoing activities of VCARE can be eventually resulted in ITUT recommendations. So I think everyone should be familiar with this IRJBQA, but I just briefly present this one for the newcomers. So IRJBQA study the topics related to video and audio visual quality assessment method among ITUR study group 6 and ITUT study group 12. So during this IRJBQA meetings, we can discuss topics related to qualities so that eventually this effort can be resulted in ITUR recommendation or report. So during these rapporteur meetings, so it's an intersectoral rapporteur groups, ABQA meetings. You can exchange information faster. You can do using email or joint meetings like this, and we can seek participation from the broad communities such as PQX. So also we can invite input from the non-member expert, and also we can keep the peoples informed at the early stage of recommendation development. So also we can possibly jointly edit the session on a recommendation for the revisions, as we did successfully in the last time to revise PIDA 910 and 913. Also I believe that the same thing is now ongoing to revise BT 500. So we have two co-chairs, me and Alex. And the parent group is ITR study group 6, which is broadcasting service, and also ITUT study group 12. You can find the relevant information on this site. So in ITR side, we have several groups, in particular Working Party 6C, which deal with quality issues. There are audio issues, video issues, and recently there are a lot of activities on the HDR. Also, another interesting issue is the immersive system, VI systems, and I believe that this sub-working group works together with ITUT, in particular study group 12, and also there are some other issues. And this is the sum of the summary on recent ITR Working Party 6C works. We have a draft new recommendation, BS 775, which deals with multi-channel stereoscopic sound systems. And we have a new report, sound test material for advanced sound systems, and a lot of report on HDRs. So you can find a lot of information from this report. Okay, let me show you. Yes. So this one was some contribution, not this time. I think it was last October input on HDR. There are some input on HDR last years, and also currently I believe there was some discussion to revise BT 500 as we did the PDA 9, 10, and 13s. To initiate these revisions, we need a contribution from a sector member or state members. And also there are some activities going on using AI or deep learning method for quality measurement, using it in particular in particular for no reference models. Also in broadcasting side related to the AIs, there are some activities and questions to apply this AI method for broadcasting applications. So we have new questions in that regard. So I think as the situation improves, I believe that we can meet in person in the next Working Party 6C meeting, which is tentatively scheduled on September. So I think we expected that more contribution on the quality or related issues during that meetings. I think that's related Working Party 6Cs. Okay, so if you have any questions, let me know. Otherwise, I think Alex can present the ITUT side.
Yeah, thank you, Trudy.
Do you have any questions here in the room? Okay, carrying on.
Trudy, can you continue sharing? Is it well enough visible? Or
whatever you want. I can control the screen, but if you want, you can do it. Whatever is fine.
Yeah, if you don't mind, I would be happy if you could just continue. It's not so many slides left, right?
Okay.
Thank you so much.
So I think
okay, so then, yeah, for study group 12, right? There, similarly to what Julie has described, there has not been a new meeting between the last week meeting and today, which is why we just basically for everyone want to recall what activities are ongoing, which could have a link to our work here. I just now see again that there's still the same bug as there was last time, but I'm sorry for that. So there's one question missing here. That's question 10, and we will have Gunilla Berntsson, who will also present the work on this XR-based telemeeting quality, right? So I really have to edit. Take a note of it now. Apologies for this. I already noted it.
Sorry to interrupt. I think, Alex, that Gunilla gave a presentation yesterday.
She gave her it. Okay, very good. Then you are aware. That's great. Then at least it's not a on purpose omission. It's just not there. Okay, so these are the questions. The work in ITU study group 12 is, like always in ITUT, organized by working parties and by questions. These questions, I mean, there's a new study period starting now with this meeting, which is going to happen in June. And so all the contributions are coming in now. The June meeting is from the 7th to, I think, 17th of June. It will happen in presence in Geneva. Yeah, and of course, I would be very happy to see some of you there. I will be there personally also. And yeah, so the deadline for contributions is the 25th of May, and which is why we currently don't have all the contributions on the table, and that's also why I have not included any here, because it would have been an unbalanced picture of what we will be presenting at that June meeting. Yeah? Because previously, I had mentioned the titles of the contributions. I didn't include this now in this presentation. So the first question of relevance is Q912. That's the question which deals with the speech quality stuff. Q13, so Q10 missing with telemeeting quality. We come to the individual questions also in a bit more detail. 13 is more holistic kind of planning considerations around multimedia services. 14 is the question I'm a co-rapporteur for. I mean, currently acting co-rapporteur because of the fact that a new study period is starting. There will be, of course, also a new decision on who will be those rapporteurs there. Yeah, and then Q19 is the one that is, where Chul-hee is the co-rapporteur in this context. Can you switch to the next slide, please, Chul-hee? Chul-hee?
Oh, okay. So I was trying to add the Q10. Oops,
okay.
I can.
No worries. No, we can do it later.
Okay.
We will send an update. It's a pity that I forgot this. Yeah. Okay, so then yeah, the work items in question 9 here, they're the rapporteur, the acting rapporteur, I must also here say, is Jens Berger, who you also know, and the work items which could be of relevance here is this perceptual approaches for multidimensional analysis. This is primarily speech, obviously, but I think it's quite interesting. That's why we included it here for this group as well, because the methods are relatively similar. Then second one, PSAMD, is single-ended perceptual approaches for multidimensional analysis. So the idea is actually that you perceive a signal and you can, for example, using multidimensional scaling or attribute scaling, you can get to a multidimensional representation using a sensory evaluation just that describes basically the percept. And obviously there has been much less, but also some work on this in video. And then you have a multidimensional space of descriptors, like when you are buying a chocolate bar or something, right? And you are describing the taste by attributes. And then the idea is that you can actually map this multidimensional attribute space, which is normally achieved by experts or by people who have at least been somewhat trained on the type of stimuli used. It's like a wine taster. You would not use the everyday person from the street to give descriptors of the taste, but rather someone who has a good vocabulary for it, for example, right? And then the idea is to map this multidimensional space to a quality evaluation using, for example, external preference mapping, right? And this is actually this work done here in these work items here. Okay, then P-ONRA, I mean, using a model, right? And the idea is obviously that you can, in a better way, then also describe why a person would be preferring a specific stimulus over another one. Then P-ONRA is a perceptual objective noise reduction quality assessment. I think the title says it all. It's about speech noise reduction techniques. And then there's PML guide. I think that's a particular one where the group could be interested in. That's a guiding document about the usage of machine learning in the context of model development. I mean, what are the boundaries there? What should be considered? Should he please, next slide? Thank you. Okay, then comes question 13. Here, the acting rapporteurs are Kazuhisa Yamagishi and Rachel Wang from Entity and Huawei, respectively. And here there are a number of work items, which are, as you can see, relatively holistic in a way, right? So they are really, when new services arise or so, then they are relatively oftentimes handled in this question 13, defining guidelines and also specifying the factors that could be playing a role, right? That's why we have, for example, this QE 5G and GQE AR, right, where it's actually around specifying the factors that can play a role for these technologies. And then we also have things like the P.O 'MMOG, which is in this case an opinion model for mobile online gaming applications, right? And that's so any kind of network planning models that are around such services, multimedia services, right? So network planning model, meaning you don't have the network already configured, but you know what you are going to be choosing in terms of codec, etc., could actually then be predicted, or can be, for these services, there can be a quality prediction being made, right? I mean, a very prominent example is the E model for speech. And then there are video telephony related counterparts like the G1070, which you may know. And there actually, the idea is that in a parametric fashion, before the service is actually operational, you can predict quality. Sometimes these models are also in scientific work used, especially in scientific work, but also practical work used as monitoring models. But for dedicated monitoring models, there are usually other activities within study group 12. Okay, I think the other ones, I think they're clear from the titles. I would like to switch to the next slide, please. Thank you. Okay, that's, as I said, I mean, question 10 is missing. I mean, it's not only missing in the initial list, but it's also missing in the long list. I'm really sorry about this, but fortunately, you have already seen the presentation by Gunilla. I'm actually also involved there, so it's a real pity. Yeah, anyways. So the work here, the work items currently still active are listed here, where there is a sort of unofficial work item, which is also in a slightly different view there, the fourth one. So the P120X guide is a document where we are, which we probably will revise. Sorry, and my acting co-rapporteur is Jürgen Gustafsson from Ericsson there. So probably also known to most of you. The P12OX guide, there the idea would be to revise it for this upcoming study period and include there also the P1203 and 4 standards, so that there's some kind of guideline when to use which of those recommendations. Then we have P1204.1 and .2. We have still not officially closed those work items. Those are actually the mode 0 and mode 1 models from the PNUTS competition that we had, PNUTS phase 2 competition, which was jointly done with VQuac. You know, that was the PNUTS AVHD modeling competition, out of which we created the standards. That's the fourth line here. The P120.4.3, P120.4.4, and P120.4.5 models, which you have heard about in previous meetings, right, where we actually summarized the results on those. So .3 is a bitstream-based model. .4 is a reduced reference model, which, however, is actually on par with the full reference model, which has been submitted by the same creators, and .5 is a hybrid model. .3 was actually developed by TU Ilmenau with Deutsche Telekom, .4 by Roda and Schwarz, and .5 by Opticom. Okay, and now we are actually working on an extension of these models for the AV1 codec. So initially those models have been developed for H.264, H.265, and VP9. And now we have actually very kindly data from NTT is being made available to us for this codec extension. But as you can imagine, it is a bit more difficult to do this for a hybrid model and also for a bitstream-based model, because there you need to somehow have a dedicated handling of the specific encoding, right? So we actually have evaluated now P1204.4, which is the reduced reference model, on the data from NTT. So NTT basically was the referee there, and the guys from Roland Schwarz have submitted the scores to NTT, and NTT has then made an evaluation, and the performance is really extremely good, we have to say, right? It's also outperforming other full reference models, and there is actually a contribution upcoming describing those results for the June meeting. And so it is relatively clear to the Q14 members that P1204.4 for AV1 will probably be standardized. I mean, this extension, so to speak, which will just be a few words, right? It works also for AV1 out of the box, kind of, right? This will be actually handled at the upcoming study group 12 meeting. For the other two, 4.3 and 4.5, it's a slightly bit more complicated because the database that we have from NTT does not allow a clean split into a training and validation set, right? It's just not so many databases that this would be easily possible. So the idea is that, thank you, Martin. Martin has actually put the link to the contribution in the chat, I think. I only see it with one eye, but I think that's it. Thanks a lot. Yeah, and the idea here for .3 and .5 is that we've basically, based on the .4 performance, we have now a set of requirements that those models should be meeting out of the box. And if that is the case, then also the extension for AV1 can be included therein, where actually the NTT data will be used to a large extent as unknown data, right? So we still don't know the MOS values for those, and we also don't have the sequences, the two institutions, TU Ilmenau and Opticon. So to keep this this extension to this codec completely clean and unbiased, so that we're not basically able to train on known data and then evaluate unknown data, right? I mean, that obviously would work pretty well, I guess. Yeah. Okay, then we have the work item PPQCG. Please barge in at any time when you have questions. I think I can also vaguely see you raising of hands if it's not the last rows. Right, so please don't hesitate if you have any questions to indicate so. Okay,
yeah,
then
question.
Please, yeah.
So the continue work, I mean, in the previous project and evaluation, there was collaboration between WICWEG and ITU. Do you see that there will be a need for that in your upcoming project?
Sorry, maybe I should be muting. It's a bit chopped what you're saying. Can you repeat this? Sorry, it was. Were you saying?
I'm just curious about if you see that there will be a need for a collaboration for evaluation of models in your upcoming work in this work item, like we did in the previous.
Okay, so the idea within Q14 is that for the moment, right, we would be primarily extending those models to new codecs, right? And since, I mean, the performance of this 12.04.4 model for these new databases is really very striking in my view. You know, I would think that we don't need a new model there, right? And since the performance of 4.3 and also 4.5 were relatively similar, I mean, not identical to 4.4, but relatively close, let me say, right? For at least for the training and validation databases we had used in phase 2, we also are relatively confident that those algorithms per se are actually good ones, right? And that it is worthwhile to just extend them when databases are there. I think it would be actually very interesting if within this group here, there were other data available, right? Like for VVC or other codecs maybe, right? Where you think we could be collaborating in this regard, right? So that we could be doing it in a similar way as for NTT, basically validating those existing models on this new data. I think that would be a very interesting collaboration. But for us at the moment, at least up to a resolution of a 4K UHD one, so basically SDR, we think that those models are good. It's a completely different story if we are planning, and I wouldn't mind this, if we were planning corresponding models for maybe 8K or HDR, right? Then it's a different story, and there I would be very happy to openly discuss whether we would like to have such a work item, right? Which could then, of course, be again happening in Q14. But for the time being, for these kind of short-term models, like we call them in question 14, right? We think that we are okay.
Could you just elaborate a little bit on the entity database? How was that created, and was it secret before you evaluated it, or was it an open database?
Completely secret. So the only thing, and also, so far we have only evaluated P1204.4 on it, right? And so the data is not available to neither Opticom nor us, right? So it has only been made available to also without the MOS data. So even Roda and Schwarz, they don't know the MOS data for the data. So it was really a very clean approach. So the data, the videos, the PDSs were actually shared with Roda and Schwarz. Roda and Schwarz calculated with their executable, calculated the MOS scores, shared the MOS scores with NTT. NTT were actually making the analysis of performance compared also to VMAP and so on. And then, you know, I'm not even sure, I have to look at the contribution. I forgot whether it's including the VMAP scores, but in the document, these evaluation results are then presented, right? And the key point is there is absolutely no change to the P1204.4 model, which is also not completely surprising because it's a reduced reference model that completely only works on pixels. So unless there are really completely new artifacts to be expected with AV1, which is not really the case apparently, you know, there would also not be any reason to believe that there should be differences. Yeah.
Okay, thank you.
Very, very welcome. And the only thing where actually we are currently working on, which is actually an ongoing work item, and so I'm just jumping a little bit in this list, is this P-Mosquito work item, which is, I come back to the other two. That is actually a continuation of the phase 2, right? So that's actually our P-Nuts phase 3, if you want. And this is also mentioned in the very end of this list here, right? So P-Mosquito and P-Nuts phase 3, these are actually linked with each other. What do we want to do there? You see, we had this modular architecture in this P1203 context, right? We have the audio quality model, the video quality model, and the quality integration module. And in PNUTS phase 2, we have been focusing on the video quality model, right? To make that better. And now we see, okay, maybe the integration module is not really realistic anymore, right? I mean, that is the one that for an adaptive streaming, I mean, especially you, Kjell, and also others in the room have also worked on this, right? So how do you integrate per time scores to an integral score when you have an adaptive streaming session, right? And that is actually handled in this phase 3 here. And P-Mosquito is basically the counterpart in terms of subjective testing, because what we want to do is we don't want to only predict the MOS score, but we also want to predict whether a person would be quitting the service, right? And this is actually then included in this new test paradigm, which is actually developed in P-Mosquito. We have quite nice first results, and I think that hopefully we will be able to submit this as a contribution as well, but unfortunately it's not that yet there, so we cannot actually share a link to it also, right? Because the deadline is only the 25th, so another 14 days to submit contributions there. Okay, then we have the 2 work items. So that's really this whole Peanuts work, right? I mean, which is really like a legacy kind of work, which we have started with Peanuts phase 1, and now phase 2 has been this collaboration, and phase 3 now is looking back again at this integration module. Now PBQCG, that's actually a work item where also parametric and bitstream based quality models are being considered. It's a more open collaboration of different parties, and there are 2 phases, so to speak, or so two components or scenarios looked at. One is a passive one, where you're basically just using cloud streaming and the person is viewing the content, right? So that's somewhat similar in philosophy to Peanuts phase 2 in a way, but specifically catering for gaming content, and also the codec settings that are maybe more typical for this application. And the other one is interactive scenarios, where really players would be actually engaging into cloud gaming play. Yeah, and this is a quite active work item, really, I must say, quite nice, where actually different parties are involved, and there are lots of offline meetings, right, that are even held outside of our weekly Q14 calls, and then are only reported, summarized in the Q14 calls. Yeah. Yeah, and of course, we are considering also the standardized models there in a way to as possible candidates, but also to supplement the work there, right? And I think there was also a presentation the other day here at VQuack for a gaming related bitstream model, right? Yeah, and obviously, I mean, you know, we always are aware of this kind of balance that you need to hit between, oh, it takes quite long to develop such a standard, but on the other hand, these standards that we have developed, in contrast to many other things which are being presented that are trained on other models, right? We have so far been really trying to, within Q14, to really have a solid database of subjective tests on which we are actually developing these standards, so that we're not training on other models, right? That's the idea. And of course, that takes longer because we need to run those tests. And in PBQCG, there will also be dedicated tests being run in order to keep this idea there. Okay, then Peter Diacosi, and that's also valid. I'm sorry, I need to say that it's also valid because obviously those existing models have also not been perfectly trained for gaming content and gaming type settings, right? So it would also be maybe a little bit biasing and misleading if we were using other models that were actually not really trained and foreseen for this specific applications to train those new models. Okay, then Peter Diacosi is an approach where these Peanuts models that I have previously described will be or are being analyzed with regard to which quality degradation type, so which factor that is actually considered by such a model is the dominating one, right? And their NTT is very active, and they have made a proposal, a quite interesting proposal based on Shapley value that actually seems to be quite promising with regard to highlighting which factor should be considered when you end up with a specific MOS score. What should you do as a service provider to improve the situation? Okay, so I mentioned already P-Mosquito, and I mentioned Peanuts phase 3. Is the other one that I didn't mention is P-Nums phase 2. We're currently not really active on this. And the question is, do we keep it? So that's something we will be discussing at the upcoming meeting. That is actually legacy work for those IPTV type services where actually only H.264 has been considered. But and there I would be very glad if I could get some offline correspondence from you guys here at VQuack. Do you think that such IPTV, so really UDP, unreliable transport-based services, is it worthwhile pursuing such an extension to other codecs, or do you think that this technology is so little used nowadays that maybe we shouldn't be putting too much effort into this, right? So I would be very glad if anyone has an opinion about this, if you can basically share it with me. Okay, Trey, please, next slide. Thank you very much. So that's Q19, and I think it would be even best if you two here are saying the things you want to say about it.
Okay, thank you very much. So Q19 currently has 4 work items. The first one is the infamous no reference models. It has been there almost, I think, 15 years. So this one I started with the multimedia project. And I think at the time it was very close. We have a recommendation, I think at the time was from the model from SciTech, but for some reasons, we decided not to proceed with recommendations, and then we tried during the HDTV and then hybrid, and also we tried during this phase 2 project. But all during this time we failed. But currently, there are a lot of activities on these issues, in particular using deep learning method. A problem with no reference method, I think, as Margaret noted during the last weekend meetings, it may show some good performance for the training data the researcher had, but when they applied to new data set, their performance shows so much difference. So I think it is very difficult. I think these issues has a serious headache for the no reference model. I think also still it is a problem even for the deep learning based method, because deep learning based method can show good performance for the given data set, the training set data set, and if the test set or validation set is similar to the nature of training data, it may be good. But sometimes with a completely different data set, the performance is so much different. So I hope that in the future that you can have some better result. Also, I think I noticed that with the VQuack has the known project, I think the output of their effort can be inputted to this work item, not only for ITOT side, also I think this good NL method will be welcome in the ITOR side. So I think if we have a good result, I invite you to commit to submit a contribution to ITOR or ITOT side on these issues. The next work item is the optimal transmission. This one is try to optimize bit rate and transmission resolution by considering display characteristic and available bandwidth, because these days a lot of multimedia contents are being consumed through the internet, also through the mobile receptions. So in such a scenarios, the available bandwidth may vary, and also you do not want abuse it, the overuse the available bandwidth. So by considering the display characteristic and available bandwidth, also sometimes it can depend on the source contents. By trying to optimize bitrate and the transmission resolutions, we try to provide the best perceptual quality to the end users. And the source video quality and the QUHD is somehow related. The source video qualities, this one has started when the IPTV was launched. Many IPTV providers, their problem is that some of their contents come from the SDTV and the old films, and some of them come from the full HD digital video contents. So quality is so much different, and it doesn't make sense to transmit SD contents in the high HD resolutions. And sometimes source quality is so poor that it doesn't make sense in sending in the high resolutions. But they have to make that decision at the head end, and this method
so this
is
guy,
also.
I don't know where they are sitting. I think in Dubai or something. The name of the company is Mozark, and so he sent an.
Oh, I hear.
He was talking to me for 2 days, and so.
Can someone mute
they're
Shahid?
looking
Because I mean,
for,
I also don't think he wants
they're looking
to
for
share
two
this.
things.
I don't want. We don't want to listen to these company informations, please.
Or anything like it. They say they are a customer experience.
This is recorded.
Probably they help.
Okay, Shahid, you're being listened to. Hello, hello, Shahid.
evaluate
Mute
the
yourself.
Customer experience of their
The
app.
Oh.
Can we stop the recording at least?
He says that they need something to help video streaming quality. So, in general,
Can somebody kick Shahid out of this meeting? I mean, I think it's on in his own security.
Thank you, Shri.
Oh, okay. Okay,
Good.
so the source quality is assessed and monitoring is, I think this one is also NL method. So the head-end operators, they want to measure the source qualities, and they can choose the optimal resolution for the source qualities. And the J.QUHD is similar to the source video quality, but only the difference is that when the UHD program is available and transmitted, sent out, and they found that there are not much difference in perceptual quality between the UHD and the Full HD for many UHD contents. It is because that when the UHD video was taken in not ideal illuminations, due to the noise and some other aspect, the UHD quality is not any better compared to the Full HDs. So in such a scenario, but if the UHD video signal is captured in the studio scenarios when the illumination and everything is perfect, UHD is much better than Full HD. But otherwise, the illumination is not ideal. The difference also, there can be some noise due to the wind noise or the dust in the air. There are many other factors that affect the UHD qualities. So in such cases, the productions, the head end should determine that this content should be sent out as a UHD or just a Full HD is fine. But determining that this issue was not easy. There are some effort. And if you go to the current temp document, there are some related work. So but this one is also kind of difficult, challenging problems. So this no reference and source video quality and the QUHD, in fact, they are all deal with no reference models. And the source video quality and the QUHD, they just apply at the head end dealing with the original source contents. So I think with the BQAG or any other lab working on these issues, that you are welcomed to submit to the contribution to progress these work items. Okay, thank you. That's all I have to say at the moment.
Actually, I have a question.
Okay.
I was thinking this no reference work item. I mean, seems like it would be a ideal case for an evaluation project. Or would you think that that would be feasible or and desirable? Or is that something you are considering within the IQ?
Yes, I think no reference. I think the crucial issue is that the method should be widely and independently verified. As you know, that there are many academic papers on no reference models, and many of these methods you can download publicly. When you download this algorithm and apply your own data set, you are getting completely different performance metrics. So I think if you have some good no reference model, I think if you can verify, I think this one can be worked in the joint, because then we have a larger data pools, and also we have a larger data pool to train the models. And then it may be possible that we can come out with a good, reliable no reference models. I think then we can collectively propose the method to be included in the recommendations. So I think this is, as I understand it, that BQAG is non-project. So I think that their effort can be result in the possible in the future recommendations of ITOT or ITOR.
Okay, thank you. Yeah, I will bring this up in form. I saw there was a comment chat. Mark about the plans for 910. Was that a question, or did you want to say something about it, Mark?
Oh, I think for some reason your speech quality is not so good.
Okay, sorry.
I'm hearing a lot of a break.
Actually, maybe this is better. So this is Martin. If you could just comment on the status maybe and the plans for P910, and maybe just inform the meeting about P913, what we did at the last meeting.
Yes, I think P910 and P913 was successfully revised by including I think a screening method from the Netflix. That was done, that was approved. But also there was another proposal to revise P910 and possibly 913 regarding, I think, SI and TIs. So we welcome in contribution to revise that sections of P910 and 913. So, but we have to walk through the revision should be based on the contributions. So we need the input contribution to initiate and progress these revisions.
I don't know if you hear me well now, but the BQuag is working on a document for suggesting revisions for P913. It's mainly led by Margaret Hinton and but that's not only about the new method, the screening method. It's also other parts of that is not considered as suggestion for change.
Yes, I think that the BQuag, there is a lot of quality work there. So I think it would be very helpful to these quality related communities if their result, their finding can be resulted in ITU recommendation or report. So but all those such finding or result should be submitted as a contributions.
Yeah, sure. I think that's what we are working towards. Any other questions or comments for Alex or Lee? Yeah, I mean,
That was again very choppy, very hard to understand.
The question was if we can have access to these slides, and I think the answer is yes, because they've already sent to us. So,
yeah, you can just upload them to the server. There's absolutely no problem with that. Maybe what I think would be nice, but I'm not sure I can do it today. I can probably do it during the next 2 days or so. I would like to add Q10, but maybe you can already upload these slides, and I would kindly ask you to replace them by an updated version with Q10, right? But then,
yes,
you know, this information is immediately available, which may be useful. I don't know.
that sounds excellent. Send them. So Margaret is send them basically to Margaret. She's the one handling the uploading. So.
Okay, so also just for just for information for those who are not familiar with ITUs, all this work item is a pre-step to be hopefully possibly resulted in recommendations. So if we have any research work related to any of these work items, you can submit the contributions to that questions so that your method might be part of the new recommendations. So those who are not familiar with ITU activities, I think you just to go to some ITT site and to understand how the recommendation is developed and finally approved. But this work item, title of this work item is a very good place to get some idea what's going on ITU, the ITU side.
Yeah, excellent. So there are no
Okay.
more questions or comments.
Okay, so I think also, I think during this ITR ABQA meeting, I think I think VCAC started a new project chaired by Yanis, but looks like Yanis is not here. So I think it might be good to know the current status of the project. I think.
Okay, could you remind me what was the what?
Yes, I send him email to inquiring the status of the project.
You will send it, or you have sent it?
I can send it.
Okay, excellent. Okay, very good. So
Okay,
then
so
if
any
there
other
are
questions or comments?
nothing from the room,
Yeah, then I also switch off my video. It was really great to interact with you briefly. I really wish you a fun time, and hopefully many of you are coming to the amazing Geneva Study Group 12 meeting in June, and we can chat there. That would be great. Take care, guys. I mean, will be following this, but as indicated, when coming up with the meeting time slot, I'm unfortunately not so well available this week, but I wish you a lot of fun, right? Bye-bye.
Bye.
Okay, thank you, Alex.
And then there are no more questions and comments for Julie. No presentation.
Okay, thank you very much.
Thank you, Julie. Thanks for a nice presentation. Okay, I think we need to think about a little bit on schedule. Yeah, perhaps that's why I would like to because we might want to rearrange this. In principle, we should have had a discussion now on the modification in this P913 because it's in the ITU activity. On the other hand, okay, I was asked to lead it, but I think not having Margaret involved would be kind of a waste of time. So if there are other rearrangements we can do and then put this discussion when she's available, I think that would be a great advantage for this. And also, I don't I don't find the link to the document, so which makes it even harder. But maybe someone could help me with that. So, but so would it be possible to move like to suggest to start IMP earlier, or are you very much needed to?
Everyone from
We can,
Yes.
I mean, we can start with the presentation that are not from Pablo and myself, published in other meetings.
Okay.
So I can
Feel free to
start with others.
Okay, so then I will move this. We have also quite full schedule in afternoon. So we probably, if we push IMG forward, we also would like to push other things as much as possible before lunch, so we can have some space for the for this discussion. So, afternoon.
The photo session. No, we will have some.
We can have one
Yes.
presentation. Yeah.
Maybe we can have fun. Okay, we'll come here. I'll pick him up and I can do the presentation.
Well, maybe you're in
Okay, he's already here.
Okay.
I just saw your message, sorry.
Okay, this one. Yeah, no problem.
Okay, so I can do the presentation.
Sharon will start.
Okay.
Okay.
I missed my everyone's so eager.
Yes.
Yeah, so I will update the schedule a bit, reflect that. So let's go ahead so we have time to do the presentation before the photo session. Just a question, is there some physical location where you are closer to the mic? Because they complained a little bit about the audio not coming out of the room properly. One of the problems that it was breaking up. So if there are, I don't know if there are net issues that the cause of breaking up. But let's see if it works.
It's shell.
Yeah. Yeah, you have network problem. Yes. You shave it from your.
Pointer? No, I have. How we do?
So you shared it on. Yeah, okay. So
That's good.
please go ahead.
Could you hear me clearly? The word. Could you hear? Do you have my voice?
I think the microphone is somewhere in the room. So
Visual. Okay.
Do they hear? Nice.
could they confirm?
Please, the one person confirm that the sound is clear. I'm on voice.
Is there anybody out there?
Are you still there?
Can you hear us?
Yes. Okay. Maybe Sean, you could check if you unmute, if you your phone. Hello? No? Okay.
Let's assume they're here then.
Yes, I think they do because Lucian is Zoom meeting. That's something.
Coming out there. Okay, so
Okay.
please go ahead.
So this presentation is an ongoing investigation that we have done with the university with collaboration with the roles, and it is titled Augmented Remote Operating System for Scaling the Smart Mining Application. But my focus is on user experience and quality of experience. And my colleague Alice Michelle Blomstrom, no, for the engaging investigation. And it is based on the effort of graduate postdoc Alice of the whole project. And I asked Lucian to borrow this slide because it's really useful and a good visualization that shows that how we could bond quality of experience and user experience to could address some complicated system when we want to ask a human to have some interaction with the systems that they are complicated and they are not easy to work. So our approach is considering quality of experience and user experience when humans want to work with the system that could be complicated and see what is their satisfaction or what is their interaction. That would be some introduction, background, and one method that we use in augmented remote operating system for scaling. It is conducted via two different experiments. When we wanted to work with the wall edges features perception, and so another experiment that when we want to understand what is the depth of 3D environment perception when operators work with the system. Then we could move on the results and discussion. For making a clarification, what is the scaling in the mine? There is a problem when miners or operators want to point to the some rocks in the mine, and the problem is that some parts during the scaling would be.
Sorry, but do I understand correctly that there is a problem with the audio outside?
My computer, I cannot. I don't know if it's
I'm not able to access the network. I don't have any.
Okay.
Yeah, because I had the same feeling that there is a problem with audio.
Yeah,
I'm trying to access my network, so this is a different network, and I didn't have any problem before. So I'm wondering that maybe you can mute the system and hear from the microphone at least during the presentation. Because I don't know how difficult.
I mean, if
I got feedback from someone who is online.
Ah, that is okay. Sorry.
Mario is mentioning this spreadsheet.
there's something, I don't know if you have the microphone, but it's like not very.
Let's go.
So, the problem is related to a scaling process in the mine when a person want to knock to the rocks and the rocks would be loose, the roof or some parts of the wall of the mine. And it is reported that the most problematic task during the mining. And in order to improve personal safety and work environment, it is an approach to remove away from the mine the operators, and they sit in another place, in a remote place, and control industrial machineries. So we need to produce augmented telepresence that that operators do not sit in a real place like mine with a hazardous problem, hazardous situation, and they sit far away from the main place and try to remotely operate industrial machineries. And they should have sense and feel of physically sitting in a main place, but they are not in a main place. They are in the remote place. So if I want to describe about challenges that they have in industrial machineries and heavy industrial machineries particularly, they have a problem with the booms when the boom block the view of operators and the obscure part of the view. And it is one problem. And another problem is that operators need more perspective view. And to tackle such problem, physically some industry involved, for example, in industrial machines, try to move the cameras physically out of place, but it is physically. And our approach is that removing the boom based on some image processing tasks, and so instead of moving cameras physically to the right and left side of the machines, try to make some new interface that we call it novel perspective, and it is a artificially move cameras to the left and right side of the machine. This investigation is done in Sweden University, and it is not in a real mine, so it is a safe environment. And what is the methodology? There are some research questions. What is the effects of different interface views on failure detection that we focused on the first experiment conducted in Munich lab? And what is the depth estimation in this task? And the second question is related to what is the effects of different interface views on controlling the robot arm when a participant wants to move the robot arm and do the tasks. And how is user experience using the different interface views on detail detection or depth estimation conducted experiment 1 and experiment 2. So it is a process and work environment that we have had it in. As you could see in the middle picture, there is a robot arm, and there is a camera that it is attached on top of the robot arm, and the robot moves and sweep the mine wall. What participants see is not from the point of view of this camera that it is located on top of the robot arm. It is based on what the camera captured, as you could see in the left image, and in the middle, if I want, this one, the larger view, stereoscopic view that we have, but in this case, just use one camera, not two cameras. We have one. We have just one monocular view. We introduced the system to participants at the first, and we had 3 types of questionnaire. The demographic questionnaire that it was a pre-work to the test, and feedback questionnaire that we asked after each test from the participant based on what we designed and based on experiment 1 and experiment 2 considering detail detection and depth estimation. And at the end, we had some suggestion and overall feedback that we asked from participants. In the experiment one, the focus was on effects of in-view augmentations and interface distributions on wall-adjacent features perception, and there were some interface and some different combinations. To make it clear, this is the 6 interfaces that we showed to the participants in the experiment one. But what is the, it is important to point that these notes that you see in the red text, it was not in the interface. It is here just for making clarify that what is the interfaces. And these 6 interfaces was not were not shown in all of the scenarios. There were some enabled interfaces that we showed to participants during the test. And we asked them about the targets and what is the target. In the first experiment, we took some photos from some parts of the mine wall and asked them to point to the targets based on the picture that they saw. So the idea was identifying the wall edges in this experiment. We had 10 participants and designed 90 targets and the 8 scenario that we call the test run, and each test run in 2.5 minutes. For more clarification, it is one of the scenario and one of the test run that showed to the participants as a run sequence 2. And it is another one that in run sequence 6, we had 6 enabled views, but in the run sequence 2, we had 2 enabled views. And left top is a left original view, right top is a right original view. The middle one is a disocclusion view when we try to remove the robot arm and have a better view about what is the behind of the robot arm. And so left and right down, it is a novel perspective view, and it is constructed from LiDAR view that you see from the middle, and it is constructed from RGB and LiDAR view. And it is the table that describes the combination of enable interfaces in each test run in experiment 1. In experiment 2, we focus. Yeah.
Sorry, the question is all happening on a screen or in a virtual reality?
In a screen. Yes, in a 2D conventional display. And in experiment 2, we try to focus on effects of in-view augmentation on depth perception, and we try to remove 3D cues because in this experiment, as you can see in the interface, there are some 3D cues came from floor and sail, and that they are perspective, and they show that, and it makes some clues for operators to know how is the depth. But in the second experiment, we tried to remove these 3D cues, and so instead of combining interfaces to show in the display, we just show one interface to participate. I mean, for example, in scenario 1, they had left original view, just this view. In scenario 3 was, for example, disocclusion view with 100 transparency. It means that all parts of the robot were removed, or novel perspective view, as you can see, and all of them were showed in just one scenario, and there were not any combination. And also we had a LiDAR view. So in experiment 2, we had 5 different scenarios with just one enable view. What I would like to say is that there were some differences in experiment 1 and experiment 2 when we wanted to show interfaces to participants. In the first experiment, we had a conventional stereoscopic view, but the view was not a stereoscopic view. And in the second one, we improved the display to show the interface to participants. So let's go to the results based on what we did. As you could see in the first experiment, we didn't have any convex or concave objects, and the wall were flat. But because the idea was about finding the cracks and some small water-adjacent features. But in experiment 2, the idea was finding the depth and understanding the tree environment. So we added some objects, as you can see. In the right part of the mine wall, we have some like card box that they are attached and they embedded on the right part of the mine wall. And so in the left part of the mine wall, for example, here, there's a styrofoam that we use them for making some depths in order and ask some question about the order of this object in depth level. So in the results, in the experiment 1, that there were not any concave and convex, that we called it hills and valleys, based on what we attached on the wall. And there were just finding, we wanted to operators come and point to the cracks. The rate of identified targets by participants showed here. And as you can see, there are some run sequences and test run. In no arrow system means when participants came and looked directly to the mine wall without any interfaces with their eyes, the result was the best. And from run sequence 2 and up to run sequence 8, the rate of identified targets were lower. But in this case, run sequence 4, test run 4, that it was the combination of original video and calculated view with 50% of transparency, that the robot arm was disaggregated just the half of them. It was 50% transparent and not completely removed. In this case, the rate of identified targets by participants were the lowest that case. Based on qualitative results, participants mainly used the top views, original view and calculation. So I mean, the top view, the left one, right one, and the middle one. In the experiment 2, results shows that there is significant differences when participants looked to the mine wall and they wanted to control the robot arm and sweep the mine wall and control the robot arm to point to the object. And it seems that left original view and the left original view and right view, there is a significant difference between these two in opinion score when the test run was just enabled in left original view and right view, and it is also show the pairwise 2D hashes result that it does not include the 0, and it is a significant difference between left original view and right view. And so in controlling the robot arm, also the significant difference when the right original view and LiDAR view were enabled. And it is showed also in the pairwise applications. And so in depth estimation, it means that when we ask participants to estimate the depth, the level of the depth in objects, color box, and styrofoams, it shows that when they point to they had a novel perspective and left original view, there was some significant difference when they had in Miniscope when they had these different interfaces as an active interface. And so in the user impression, when we ask them, what is your impression when you want to work with the system, based on their opinion as well, the left original view and wider view has a significant difference in MOS. And it is shown in two cases also, and in user impression, there is also difference, significant difference between the right original view and wider view. Based on comparison between experiment 1 and experiment 2, it shows that there is no significant difference between disocclusion view and novel perspective view in both experiments, but in the user's MOS for disocclusion augmentation view, it shows that it is higher in experiment 1 than experiment 2. And the reason is that in experiment 1, we had two different transparency, but in experiment 2, we had just one 50% disocclusion transparency. And in disocclusion augmentation view, there is significant difference between participants' MOS in experiment 1 and experiment 2. And so in the novel perspective views, score of users are almost the same in both experiments. Discussion, I could say that based on qualitative and quantitative results, quantitative results in experiment 1 overall show that there is no significant effect of either disocclusion level or novel view presence when user has these two interfaces. And so in qualitative results shows that disocclusion was beneficial, and the impact of disocclusion view is offer than novel perspective views on participant opinions, and participants didn't use novel perspective views in some cases. So it shows what is important here is that some results do not come up from quantitative results, but in qualitative results, when we gather some participants' feedback, then it shows us something that it might be different from quantitative results. At least the experiment 1, the results shows like this, that they used disocclusion, but in quantitative there was not a significant effect. But in Arrow's experiment 2, in controlling the robot arm and user's impression, there are significant differences between left original view and LiDAR view, and right original view and LiDAR view. The reason might be comes from the LiDAR view. Participants saw the LiDAR view that it was black and white, and it makes some differences when they look to the left original view and the right original view. In depth estimation and significant differences, there is a significant difference left original view and perspective view. And so the impact of disocclusion view is lower than novel perspective views on participant opinion. and the user was not satisfied with the clarity of novel perspective and rider view, but finding depth views was easier with this augmented reality. Because I mean that in the novel perspective view and rider view, the quality of interface was not good enough, but they helped the participants and the users to find the depth better. And in all future work, based on the results came from experiment 1, from a methodology standpoint, there's a need for redesigning test environment. And there's a need for improving the resolution of the camera and so improve the resolution of the display. And there were a problem in memorizing the targets in experiment 1 that we tried to prevent it in experiment 2. And one of the problems that we had was that the robot arm was really small, and if it would be bigger, it could obscure more. And this conclusion view that it removes this occluded when whom occlude the view. If it would be bigger, when it removes, but overdose could have a better view compared to when they have something that hides the view. So it would be good if we could use a bigger robot arm than what we use. And in experiment 2, there were some suggestions came from users' feedback that shows that adding camera view attached on the robot arm would be useful because participants could see from the view of the LiDAR view and the stereoscopic view, but they would like to have a view and they would like to have their eyes from the top of the robot arm when they sweep the mind wall instead of having another view from the base that we put camera on it. And so in this occlusion view, still there is a need for more obscuring targets as same as the previous experiment. And using augmented depth guidance on top of each enabled feature is another suggestion came from participants. And so there is a need for improving the novel perspective quality. It is all in all that we worked and present in one conference, and there are some investigation, and based on the results that we gather from users during these 2 experiments, and now we are working on a journal paper to expanding that results to the work. That's it. Thank you.
Questions? And Lucia was first. What's the time?
I'm wondering because if they have to detect something, so how you? I understand that you have the same user as different interfaces, correct?
You mean that how we showed the interfaces to participants?
Yeah, it's like what you did to make sure that if I detected it using the left original, and then I use the right original, so I should be detecting something else. Because if I detect the same, then the results are
I
biased.
understand. In the questionnaire, we divided mind one 3 parts. For example, here in the training part, we told them that this is the mind wall, and from here to the right, it's the right part of the mind wall. And from here up to the styrofoam, the middle part, and from here to the left part of the mind wall. So they know that the mind wall is divided to 3 parts. And then we asked our question number 2, based on these 3 parts. So they know that when we want to ask about the level of depth in card box. They are asking the question related to the right part of the mind ball. So they looked at that part, and there were some laser pointers that we have them do.
Okay, but means that there is one yet level of
No, Mama, mira, do the reading. Mama, mira, do the
error
reading.
or noise that
No,
is coming.
Mama, mira, do start already.
So there's one more level of noise coming from the fact that maybe a certain part of the wall was easier in detecting some things and the other part was not.
Exactly, it is really nice question because it is the problem that problem because you could see a styrofoam here and it is smaller, but it has different color. So when we ask them to point to the different level of depth in order this part, and they know that okay, there are some colors on it, but it is smaller compared to the card box that we have at the year. So in some cases, we ask them just point to the styrofoam and their colors, but they went to the mind wall exactly, and they estimated that, for example, this part is a hill. That it is, for example, in the level depth order, it's number one.
Oh.
And so we might have some problem, some errors in this case, and it was visible in some view like LiDAR view, because in LiDAR view there is no color at all. So we need some validation. And based on what we asked them to point out to the targets that they choose, based on the camera that was there, and they didn't have any view from that camera, but very blind. They could took some photo based on what they had. They had a remote controller to take a photo remotely, and it was one type of validation that it is an error or not. But there was a test leader there, and after each test run, they check that is it the correct answer or not.
Okay.
Yeah.
Okay. Yeah, difficult. Sure.
Thank you for the presentation.
Thank
You talked about the mean of neon scores. I didn't get it based on question.
Yes, in the experiment and the question number 2, we run one enable interface and called it scenario, for example, 1, and we asked some questions. One of the questions was related to how you could control the robot arm when you have this active interface. For example, when you have a LiDAR interface and you want to control the robot arm, how is your impression in controlling the robot arm? And they, for example, in robot arm, they have some problem with the shadow of the robot arm. They could not recognize it is a robot arm or it is a robot arm because there was some shadow. And in the original view, it was okay. But in this occlusion view, because all part of it was 100 transparent this occlusion view, they missed where they are. And yeah.
And I think also for the most part, they had a scale that they degree of.
Oh yes.
So
I
That's
miss
not
it.
like, but
Yeah, it is a Likert scale, and we define that distribution 1 to 5 based on your impression. Yeah.
one question was about how easy it was to control the arm. The second
Yes.
question or other question were about
The second question was about the depth information? How could you understand the depth when you have different? And the last one was about their own impression when they work with this.
So I think just a very brief question. I think we have the session to be done behind. So one short burning question out of those.
Pablo and myself, we have prepared about the test plan that we are trying to launch. Pablo, are you ready?
Yes, I'm here.
Do you want to share the slides yourself, or do you want me to?
Okay, I can share. I only need to find them.
But maybe then you have your control on the slides.
Okay, yeah, makes sense. Let me open them. Sorry about that. Just came out from a different meeting and. Okay. I will start sharing and then you can share your part. Let me find why it's so difficult to find the share button here. Here, okay.
Just in the bottom, yeah.
Yeah, it was okay. Let's see. Yeah, can you see my slides?
Yes.
Okay, so this is a follow-up from the previous presentation in last GeekWork face-to-face meeting, where we discussed what to do next as a team in IMG. So what could be our next joint effort? And basically, we decided that effort should be about evaluating task-based or more interactive use cases. And this is more or less how we've already framed the problem. So imagine that we have an immersive communication system which is bidirectional. And that's kind of important to frame it. So it's bidirectional, so we have interaction, and it's immersive, of course, and it's a communication system. So basically, we need to communicate to people who are in different locations. So this is basically the framework of our approach, and it's a system. So we are kind of trying to evaluate the system or to assess the quality given by the system, or basically to help system engineers and providing them some information about how the system works and how they can create better quality of experience to the users. And there are some methods in ITUT that have been kind of developed for different types of interactions. So, for instance, the P920, which was centered, for instance, on video conference, which is a similar idea with different technology, 20 years old. So maybe we should kind of update it, because even though it describes some tasks which are widely used in the literature today, like building a Lego block, maybe it's not perfect or not sufficient for this kind of more immersive communications. So in fact, as Gundila presented yesterday, there are initiatives in ITUT, and we're kind of engaging with them on trying to address this topic. This PQXM is defining best practices for QoS assessments of telemeetings. So this is kind of the same use case or a particular version of this use case, but it hasn't given yet to the detail of proposing evaluation tasks or methodologies. So it's a bit more higher level so far. So this is where we are in the problem level space. And so we thought that it could be a good idea to have a joint experiment to try to figure out how a good methodology would be which is able to be used with different types of communication systems, because what happens here is that like for video conferences, for instance, or for, of course, for video consumption from, let's say, television or streaming or whatever, it is kind of clear how a system looks like. But in this case of new immersive systems, there are many different ones. So we are trying to figure out a way to create an experiment which can cover kind of the basic functionalities of a large number of different systems. Kind of conversation between people, or maybe discussing about something happening in the share of the immersive space, or maybe interaction with some objects. So basically creating a basic experiment, kind of the Lego block experiment, that can be used in a number of different systems, so that we have like some tasks that are maybe simple, but can be used like as a low-level approach to test different kind of systems, and therefore there is a baseline to test some of them, and there is kind of a reference experiment that people can use when they build their research on top of that, or when they evaluate the system on top of that, and they can refer to that reference experiment and that reference methodology that could also input ITOT for standardization. So this is more or less the idea. So kind of learning by doing the experiment. So instead of just proposing a methodology to ITOT, so test the methodology beforehand and see if that makes sense, if that applies to different systems. So this is where we were in December. From then to in the last few months, we have been doing a bit of literature research or to try to frame a bit better the problem. So basically, to try to figure out how many different systems are there. So how many different types of systems we are addressing, and how people evaluate those systems in the literature. So how many different tasks are there in the literature that we could try to use as example for our basic tasks, and which kind of, and how this evaluation are being done. So basically, which are the independent variables that people evaluate, the system factors, the conditions that people can touch. So in the coding, traditional coding experiments, it was typically the compression, the QP. So which is the QP that people can typically touch in this kind of systems, which are the independent variables that are normally taken into consideration, and the elements, the QoE elements, the visual quality, the audio quality, the experience quality that are typically measured in the literature. So, and it's also, it's submitted to publication, but there is, or will shortly be, I don't know, Jesus, an archive preprint for that.
Will shortly be. I hope
will
tomorrow.
Shortly be.
I will the link in the minutes tomorrow.
Okay. First of all, we try to find out the different approaches to do immersive communication, meaning to go beyond this communication that we're having today. In some systems, do the approach of looking through a window, so kind of the same paradigm that we are having today, but with a more realism. So focusing on visual communication, on being able to put people face to face and communicate with each other as if they're looking through a window, really. And this is an example from Google, but there are others. There's another paradigm, which is the social VR platforms, kind of the metaverse-like paradigm that people share VR location. This, we have tested it in virtual conferences as well, and they share the same space. So they normally don't see each other, but they see like avatar representation, but they are immersed in the same shared space that they can interact with and interact with each other and look around and walk around and so on. And a different communication approach, which is mostly used in remote collaboration. There are also some commercial initiatives, but a ton of papers in the literature has to do with, this is the typical paradigm of a person like wearing a 360 camera and a remote person connecting to that camera and being able to look at the same location for collaboration. So here the idea is remote presence. So I have a user who's local. This is typically in telepresence terminology, and a remote user is able to connect to the location and see the same things that the local user is seeing. So they can discuss about the environment, navigate around the environment, or different kind of stuff. So in this case, what is important is that people is able to go to the location that the other user is. And there's a fourth dimension, which is slightly different to the other three, which is, okay, not only being able to see and talk to the other person, but also to somehow feel myself embodied in that common world, might be virtual, might be remote, and be able to physically interact, or if it's virtual, locally, virtual interact, but ideally physically interact with the world, like in the experiment that Jill has presented, sometimes with the control of machines, or being able to actually have some physical impact in the other end, because this is something that you can do when you do normal personal face-to-face communication. So we, after researching a lot and looking all the, searching for a lot of systems in the literature and so on, we have found that these are like the four more typical building blocks that we can have in the kind of systems that we are going to evaluate. So, and we have named them like face, the ability to see the other person, visit, the ability to see the environment of the other person, meet, the ability to share the same space as the other person, to be in the same physical or virtual space, and move, the ability to control objects, to touch objects, to interact with objects in the space.
Pablo?
And yeah?
Can I have a question?
Yes, of course.
I was just wondering, in this space, where would you kind of put the remote maintenance scenario, where you have someone at the, let's say, a base that communicates with someone?
Sorry.
At the remote location to give kind of instructions. So there is a two-way communication, but they at the same time try to solve a task at the remote location. Where in this space would that fit in?
These systems are typically asymmetric. So this is something like this, for instance, like, there's someone local.
Kind of similar to that, yes.
So yeah, so to build this taxonomy or this classification, and I have a slide later, maybe explains it better, but we thought that this might be the building blocks, but it's also important that we are considering this from the perspective of the receiver of the communication, meaning that an asymmetric system might have one way which have some elements, and the other way which have another different elements. And so typically in these remote support systems, normally the people who is remote, let's say, is having typically visit capabilities, so he should be able to see what the other person is seeing, and depending on the position of the cameras and so on, it might be able to see his or her face or not. But the typical, system will provide like this. So we'll mostly be focusing on this visit paradigm, and the other is doesn't have any of these particular elements fully, because normally the other person doesn't have the full view of the like the local person doesn't have the full view of the remote one, but they share some kind of interaction, so they both should have some level of let's say, of interaction capabilities with the system. There's a little more discussion of that in the paper, but let me go to the next slide, because what we see here is that when looking to those systems, if we think about this kind of immersive personal communications, it looks so. It is quite possible to kind of classify most of the systems into one of these archetypes depending on the type of the elements that they have, because basically these three communication elements for logistics reasons are very difficult to address simultaneously. So it's very difficult to be in let's say in a physical location, also see the person in that physical location in real time, and also have the feeling that you are actually sharing the same space. So kind of in a symmetrical way, because the other should have like being able to share your space as well. So this complete like full teleporting or shared reality paradigm that we have named distributed reality is something that for which there are not actual existing working systems yet. But there are systems like the three that I have mentioned that focus on these three kind of basic paradigms, and there's also the possibility of adding like real-time video avatars to the meeting, so we can have both the face-to-face and the shared VR experience in kind of social XR systems. We can also put like the immersive communication system outside the head of the remote person and being able also to be able to talk to them. So it kind of having immersive telepresence. And in this kind of systems, and maybe this answers your question, the remote assistant person is probably going to have like a visit sensation, while the local host is having what we have typically called the AR host. So he is able to more or less feel that the other is in the same space as he is, but with some limited capabilities. So this is kind of the type of system or of communication paradigm that we apply. Or in some situation, only have audio back channel or audio with some presence indicator back channel in some of the words, which is not immersive, of course, but it's part of these systems for the back channel in some locations. So this is more or less the space of the systems, and probably these are, as I said before, because this idea of immersive digital twin, also described in the paper, is not very popular. So it could be like having a shared VR environment, so the typical server environment, but where the environment is not a pretty virtual one, but a kind of a digital twin of the physical world, which is something that might happen, but it's not very popular today in the literature. So maybe this is mostly what we are going to the type of systems that we are probably addressing, and maybe the AR hosts should be also considered as part of the remote systems. And the thing is that if you look at the literature as well, what we have found is that the systems that provide these capabilities have similar technical implementations. So there are not so many options, at least in the basic level. Of course, in the details, there are a plethora of them. But in the basic level, there are not so many different ways that people are actually using to implement those systems. And there are a bit more detail in the paper. I don't want to be too detailed now, I think, because there are still more things to present from Jesus. But bottom line is that we have kind of tried to categorize a bit the systems, and we think that we have a reasonably good description of how the systems look like and how we can, which of them might be comparable with each other and which of them maybe not. And this is where I hand over to Jesus, which is the second part of the paper, which has to do with, okay, when we have those systems, how people is testing and interacting with them. And maybe now,
maybe I can share.
I stop sharing here, so you can share it from now.
Okay, so these also were the basic questions that we posed in the last big web meeting. We wanted to address which is, or think about which are the minimum number of tasks that we can use to test the different systems. Which are, if there are tasks that can be affected by the technical limitations of the system, that is what we really want to evaluate. And in this sense, which are the different quality of experience features that we have to evaluate in terms of low level, so more related to task performance, visual quality, etc., and also high level features like presence and others that we will see later. And also, how can we measure that with questionnaires or other type of sensors? Thinking about these questions, we started to do a review of the state of the art of different studies that we have identified, and they are in the paper. I will share the link tomorrow so you can check more details. I will be a bit fast now, but the idea is that we identified in these works the archetype according to the description that Pablo has already described, the context of use that they were proposing in those papers, like conferencing, also playing games together, or doing things together, like watching videos, sharing photos, something like that, and also remote collaboration, like the scenarios that Shell was mentioning before. In these works, also we identified the task that they were proposing to evaluate the performance or validate the performance or the capabilities of the system. We identified 3 types of tasks. Mainly, all these tasks are like involving communication. So we know that they can talk and they can communicate, but we classify them as deliberation, that is conversation, normally towards some common objective. So it's not just like talking, but maybe solving some kind of puzzle or some Lego blocks or something. So they have to cooperate in the and discuss in the conversation. Exploration, that is more related to the exploration of the environment or identification of objects, both in the physical space or in the virtual space. And finally, manipulation, that is that interaction with the system elements or even manipulating physical objects. We also, so these are some examples of these 3 types of tasks. So all of them are communication tasks. And in terms of deliberation, for example, there were some works where the users had to comment on the shared content. If they were sharing photos, so they have to comment on that. There are other tasks that involve negotiation to reach a common agreement, or even play games that are more in the communicative way, like tell a lie or some riddles or something, and also some semi-structured interviews. So maybe you can have a dialogue with somebody, simulating some kind of context or whatever, following some kind of semi-structured interview. In terms of exploration, we have, as I said, identifying and locating objects, exploration of the remote environment, or even follow characters or avatars that are in the virtual environment. And finally, manipulation. So manipulating or placing different objects. We talked about the Lego blocks experiments, and also in the remote assistance scenarios where the remote user can manipulate physically some objects following the indications of the other persons. So and also when you are like in a virtual environment, interact with the virtual objects in terms of using objects that you use in the games, or press some buttons or some interfaces in the environment. We also identified the different conditions. Normally, these tasks are evaluated in different conditions in the system. Mainly, or at least the first approach is to analyze. Consider the system that you are studying, and then evaluating the same task with previous technologies or some other alternatives, or even the face-to-face scenario. And also there are other factors, like more in the technical aspect, like display types, visualization of pointers, etc. Different embodiment types, or even latency, or the use of controllers. So there are different conditions to do the same task and then validate the capabilities of the system. And finally, we identified also these quality of experience factors that can be, or that have been evaluated in these works. We have classified them in high-level features that focus more on the user, on the cognitive or psychological aspects, and also low-level features more related to the technical aspects of the system. And we also identified how they measure these features in these works, and mainly using questionnaires, but there are some others that in fact they not that much, that are using like psychophysiological signals. So in terms of high level, we have here the list that we have identified: presence, workload, simulator sickness, quality of interaction, etc., immersion, and also the global quality of experience. In terms of low level, we have identified like task performance, visual and audio quality, usability, responsiveness, and latency. As I said, the high-level features are mainly used, evaluated by questionnaires, while the low level, there are other objective measures, like, for example, the completion time of the task or something like that. And there is also in the paper a list of the different questionnaires. There are some that have been used widely in the different studies, so there are kind of standards. There are also some modifications from these traditional questionnaires, and we have also mentioned them. So with this is like a starting point for us to start maybe specifying some details of the test plan. So here are more the next steps that we wanted to address. This is also from the other meeting. So we have already identified some interested people in different meetings, and here is a list. And if you want just to follow up on this activity and join the effort, just send an email to me or Pablo, and then we will add you in the loop. We have to identify the system that can be evaluated in this test plan. We have already in the list the social VR system from CWI, the Nokia OWL, the OWL from Nokia, a free viewpoint system that we have at UPM, or even the system that they have at RISE. And if you know any more, we can also take into consideration. And so the next steps that we will do, or try to do more like in the following audio calls, and more like with the people that want to be involved in this, is to, after identifying these systems, to characterize them according to the archetypes that we have talked before, determine which factors can be tested, and especially we consider that these factors can be used to compare the system with others. In this case, we have to verify that all the systems are share the same fundamental elements, so the comparison is kind of fair. Or we can even test different configurations of the same system. So we have to identify the set of tasks that we have already identified, some of them in the state of the art, also the relevant factors that we want to measure, redefine a bit more the task according to what we have done before, and then select the right assessment tools, not only questionnaires, but maybe also trying to use sensors, always looking for an evaluation as non-intrusive as possible. And this is what we want to do from now on, and especially in some future calls. So that's the last slide. If you have, I don't know if Pablo, you want to add something. If not, we can have some questions maybe.
Well, yeah, just reminding that even if the method itself is for evaluating systems, our intention now is not evaluating systems, but evaluating the methodology itself. So kind of the target of this is trying to figure out which the right test is, and see which kind of information we can extract from the test. So we are kind of in the phase where the system is kind of given, and we are not so much interested in assessing systems now. We are more interested in finding methodologies that people can use to assess their systems, which is kind of the other way around of a typical situation.
Yeah, we have questions here from Lucian.
So from my side, is first is kind of declaration. I would be very much interested in being involved. Can't me.
I think you
the other thing is that I'm wondering how many of those papers really distorted networks, so did some optimizations? Because like I have a feeling that the moment we don't do any optimization, then it is really UX study, not the QE study. So I also think that this would be beneficial to really understand the difference, yeah, where we do some optimization of the system and think about it, and its important part, and where we optimize the interface and the interactions between users. Because when we optimize interface and interactions, then we definitely should go into the UX community much more. And I understand we can read those papers, but I'm not sure if this wouldn't be like nearly necessary to have some people that really work on it, yeah, like really, you know, before we produce something. And for me, as always, it will be questionable that we should define a UX studies. In my opinion, we should be thinking about studies that are involving some optimization. It could be energy optimization, it could be network optimization, doesn't really matter, but some kind of optimization. If some kind of optimization is involved, then the methodology become also very different from UX, because you have to test a couple of different settings. Yeah, because this is the biggest difference in my opinion. In UX, it's quite often you have discrete different things to compare, but we have a continuous thing to compare, like a bit rate, like energy consumption, like resolution, whatever. Yeah, and this can be challenging. Yeah?
Lucian, just to clarify, when you say optimization, do you mean that you have a variable in your experiment where you can manipulate it, or do you mean optimization, like you try to? I mean, so from my point of view, I mean, when we do quality of experience experiment, we have an underlying technical variable that we could control, and then we see how it affects the interface and get the response from the test subjects, and then we get the relationship between this underlying technical variable on the user responses. But that's not optimization. Optimization to me is something that you try to find the optimal setting for a system. And maybe you can do that after the experiment.
Yeah, fully agree with you. It doesn't have to be the goal of the experiment to find an optimal bitrate, for example. Maybe it doesn't exist, but it would be more like to be able to control the system in the future. Yeah, so knowing that with this bitrate we have this quality. Yeah?
Okay, I understand.
Or going down with the energy consumption to this level, we dropping certain percentage of the quality. Yeah, and things like that.
Yeah, so this was the idea with the overview. So mainly the works are from the UX community, and there are not that many low-level features that is what we call like latency or video quality or something like that evaluated in those studies. There are some, but not that much. So that's why we think that can be something to do there. Okay, so it's not.
Okay, so the idea is to target those continuous values. Yeah?
To evaluate some technical values also. Yes.
We had in our paper. Huh? We had in our paper.
Yeah.
Yeah.
Pablo.
Yes, so this is then even more interesting for me. Yeah.
If I may, I mean, the problem there is that we have very different systems, very different content. So even defining some requirements like latency or bandwidth, it's going to be very difficult if one sends images and the other sends meshes and the other sends point clouds. They're very different. So, I mean, we can evaluate the same set of requirements in different systems. It becomes very difficult to then compare the systems, which is not what we want to do in general. But then it's a very broad scope, right? We have very different systems, and we have, all of the requirements will be different. But personally, what I would be very interested in is how we evaluate this. Because right now there's nothing. Like defining the low-level features is important. but also defining how we evaluate that. Like, I understand that it's in between the UX, but there's some things to be said about. So for example, one problem that we had recently was with what tasks you give, and that is a task to evaluate quality, visual quality. So it is a low-level feature that we're evaluating, but we don't know what task to use in order to evaluate it, because if they're too complex, maybe the VR headset is a problem. If they have to move too much and they have a cable, they might fall. If you don't have a cable, then maybe you don't have enough bandwidth in order to render, and so on. And then like identifying the task in itself is a big problem that I think would be related to what we want to analyze here. So a task for visual quality or for audiovisual quality would be very different from something as about the usability of the system, which would be the UX.
Yeah, so this is totally the focus, as Pablo said. So it's more to find the methodology, the task that can be used in this kind of evaluation of the systems, the features that can be addressed. So it's more, that is the objective of the activity.
But it can be nearly impossible, you know, if the systems are very different. So I understand that also on the table is solution where we, instead of inventing a task, we invent a method that is a little bit under the task, yeah? This would be also a solution, yeah? I guess. Yeah, but this is, let's say, very theoretical discussion.
Yeah, something.
Yeah, I don't know if Pablo wanted to clarify.
Yeah, I don't know who spoke before because I don't have enough resolution in the image.
What's your name?
I thought so, higher, but you were too far away my image from to be sure. Yeah. So this is kind of the idea. The thing is, if we so in my mind, we should try to keep as close as the underlying communication system and communication technologies as possible, like kind of the technical system itself. And it's also why I'm trying to push the focus into the systems rather than in the experience or the use case. Because if you think about all the different things that you can do with that, and you go to the UX community or to more broadly to the human-computer interaction community, then you have like a huge number of tests and a huge number of extremely different things that you can do and test. But if you think about the fact that you are communicating different spaces, and that what you need to produce is, some basic features like the ability to see the other person and also to have like nonverbal cues, like face-to-face communication, that kind of stuff, or the ability to discuss about the environment and then see how the environment looks like, and or the geometric capability of being in the same space and somehow sharing the same point of view, or this kind of stuff. Those things are quite perceptual rather than a bit lower level in our system, a bit closer to pixel evaluation, but in an immersive way, and they can be more easily affected by restrictions, which is what kind of Lucian said. So by communication restrictions, which is the bitrate restrictions, and by energy restrictions, which is mostly computing power restrictions, which are quite important in this world for the things that happen kind of locally, because there are a lot of rendering restrictions and this kind of stuff, which is where energy goes to. So at the end of the day, it's easier to find like this thing. So this is where, of course, it might be impossible to have something which really applies to every possible system and every possible use case. But the thing is trying to be, the alternative that we have now is that either we take methodology that were designed for something completely different, or we create our own, and then we try to fill a bit this gap to give people tools to evaluate their systems and to design their systems. So in this way, if from the QoE perspective, as Lucian said, so people building system is able to have a way to say, okay, I have put enough resources on that, or I should put a bit more, and people notice the difference or not, in the sense of bandwidth, of computing power, or this kind of stuff. So this is where we are. Of course, it has much more levels of freedom than the typical streaming scenario, or, you know, compression, video compression scenario. So let's see how far we go. But I think that if we are thinking about immersive media, we should somehow try to address this problem, because, you know, otherwise we are focusing on use cases which are not very relevant from the user perspective. I mean, 360 video consumption, which is what we have been doing so far, has some limitations, and people is doing other stuff with XR technology. We should be somewhere in that space.
We have
More questions.
Yeah, I think we have to close, no? We are a bit late already. So as I we can. So yeah, I will keep you. I mean, if you are interested in joining the discussions, just let me know, and we will try to send emails and schedule some audio calls in the near future.
Yeah. We have also 2 more presentation in the IMG session, right?
Yes.
And Norm and QAH and the I2 activities for the rest of the day. So we are very much late on the schedule.
I'm so happy I've pushed to finish some yesterday.
Yeah, I'm very happy that you did. So yeah, I read that. So when are we going to be back? That's today.
We'll try 1 hour and 20.
So 1.5 hour. Can we be back in 1.5 hours?
If nowadays even I propose an entry and dessert. No appetizer, no dessert.
So you will eat a lot tonight, I'm sure. So so save some space for tonight, and we eat a light lunch and be back in 1.5 hours.
So if you want dessert, you can come back over and take the coffee. Yeah.
Okay, let's go.
For drivers, we are going to Louvre, Croissant, Rue de Trier. You can keep same cars than yesterday it worked for you.
So did you post when we are back?
Okay.
Okay, I think you are already in the list.
Okay.
I mean, I don't know.